Okay, so I'm gonna show you spheres. See, these are all images of sphere. I'm taking one simple one so that I could explain to you from the internet. Oh, let's take no, which is more. Okay, let's take this one. It went to the article. I don't need the article. Okay, there was very good one search last time. It have more. Yeah. So I'm taking image format for drawing planet. Yeah. Yeah, guys, look at this. This is a sphere, a ball. Okay. Mm, blue, red, or black. Okay. Look. So a sphere is like a ball, as you can see. Okay. And a sphere, when divided into in the middle, so you see we will get uh, two circles. Okay, one upper circle and another lower circle, like this. We divided this sphere into two parts. Okay, we divide this in such a way that we cut this through the center, passing through the center of our knife. Then it will be divided into two pieces. Okay, we call this hemisphere. Hemi mean half, sphere mean sphere, this ball. Okay, and so each of one is hemisphere, right? Hemisphere. Well, so if you see date,
Yes,
how,
sir. I see only
sorry,
Google page.
you see only Google page?
Yes,
You do not see my image?
I can see only Google page.
Everybody is like this, gentlemen?
Same here, Mr.
Yes,
Okay.
Mr.
Why the app is not responding? Okay, I do one thing again. I will go to stop it. Desktop window, share screen. So yes, I was sharing the screen. Now you see it. Maybe it was stuck, huh? Maybe it was stuck probably. Now you see my screen? Hello?
Yes, mister.
You see my drawings?
Yes.
Okay, so I took this sphere from the Google. Uh, so I tried to draw this sphere here, and then I divided this into two parts in such a way that the cutting my knife go through this center. Okay, so it is each part. We call each of one, this is hemisphere, and the circle we obtained, they are called great circle. They are called great circle. So you see this orange, this yellow, and this red. They are great circle because their center, they are pass. Their center is the center of the circle. If I connect them, okay. So this is a great circle, and its center is the center of the ball. Similarly, look at the blue one. It is another great circle, and its center is the center of the ball. Similarly, the blue circle, so three great circles have been drawn on a ball. Okay, all of them have center at the center of the ball. And if we cut the sphere here, okay, so we will get little small circle. If again we cut it here, so we will get we'll get more small circle. So the great circle is the only circle which pass through the center, which is the center of the ball. The center of the small circle are not the center of the ball. They are small circles. Similarly, if we cut down into more circles, their radius will be small. This radius will be small, this will be small, and if we further divide this, so this radius will be small. This is the biggest radius which pass through the center of the sphere. So that's why we call it great circle. Right? So there are a lot of small circles, and we can draw a lot of great circles, In this question, in this situation, I will try to find some more images where they have shown small circle. Okay. Small circle nowhere. Anyway, if we look at this one, okay, so we can see small circle up and down. Yeah, this one is super. So I'll take another image for explanation. I'll come to this back. Okay, I need to save it because we should be clear today about the great and smaller circles. We are today ME1A lesson 6.1. Today is 29. Okay. Okay. I want to go for a new one. Yeah, look at this. So I believe that great circles, all the line passing through the poles, you see they form great circle up and down, because if you take any of the circle, okay, which passing through both the poles, they will be great circle. Their center will be the center. So all the circles coming up and down and passing through the poles, all of them will be great circle. This is pole of the earth, north pole, and here inside will be south pole. So all the circle coming from top to bottom, all, look at this circle. Okay, if you see it carefully like this, so the center will be the center of the ball. Now the small circle I will show here, you see this is a small circle. Okay, because their center is not the center of the ball. This is a small circle. They are small circle, I believe. And I think this is the great circle. I think, okay, here not shown probably. So because the center of this, if I change color for it, so this looks like a great circle. And if you go back from the earth, so this will be the center. So this is great circle. But all of them, which is coming from top to bottom, passing through, all of them are great circle. Okay, and it's not necessary. We can also draw the great circle this way. This is also a great circle. And similarly, we can also draw a great circle this way, because their center is the center of the ball. Okay, I'm going back to my previous image. Here I think. Why not come in? Today the system is not happy. I don't know what's the problem. It's giving me tough time today. No problem. We'll go to this again. We'll take it from here. And I will try it. Okay. So now I'm explaining the spherical triangle. Spherical triangle. Okay. You see, if we draw three spherical triangles in such a way, all the spherical triangles, so two of the spherical triangle are intersecting each other, and then with the third one, here, here, and here. If where these two circles, the yellow and the blue circle, are cutting each other this point, if I connect this point with the center of the ball or the center of the earth, like this, similarly, where it cuts the yellow great circle and the red great circle at point B, and if I go to the sun, I connect the center of the ball, we'll get this line. Similarly, the red and the blue great circle cut each other at C. When I connect them inside to the center of the ball, okay, then this triangle is called, actually when we draw this triangle is looking like this. Okay, so it has three sides. This is C, this is A, this is B. If that was the center of the ball, so when we connect uh, this point A to the center, then point C to the center, and then point B to the center. Okay, we can see this practically. What kind of shape is this? It is like cutting something from there was one very beautiful shape I saw it. So thanks to these internet sources, otherwise it would have been difficult to explain it. We have lot of shapes. Yes, one is this. I just saw one very beautiful image for the demonstration. It passed through my eyes. One is this, but there was one which was one is this, and there is, okay, let's take this one. Maybe in this category we find some. Okay, so let's see. When we cut something, when we draw three great circle and they cut each other at point A, B, and C. A, B, and C. So it's like we are cutting the ball inside. We get three planes on it. We get three planes on it. I have to take another one, so let's save it again. So look, okay, I can explain even here now. So this is like a plane, straight plane, because we cut this with a knife. This is like a plane, straight, and this is another plane. We cut into the ball, as you see in this shape. Okay. Now ABC, the angle at this point is called alpha, they are writing, and the angle between the two sides here is beta, and the angle between its point C is gamma. Okay, so this angle is gamma, this angle is alpha, this angle is beta. Okay, because of A, B, C, like this. When, one more thing, AB is not a straight line like the normal triangle. ABC. Here AB is a segment, but here AB is an arc. In arc, here we'll measure them in angle. So the name of this arc will be gamma. Will be okay. Gamma, not gamma. Let's see this thing. They are doing extra things. I should take this image. This will be, I'm not taking gamma, I'm just using ABC. That will be good enough. So this alpha, beta, gamma is a little confusing. Not confusing, but I want to go more simpler. Yes. Okay. So I'm not using now any more alpha. This angle is A, this angle is C, this angle is B. They dotted are the great lines and they give us a triangle. Okay. This is one surface, this is another surface, this is third surface. Okay. If you see at the center, okay. Okay. So in routine, if you remember, if we had A, B, C and triangle, we call it A, we call it B, and we call it C, small c, right? So the same way, you see this side is A, this side is small c, and this side is B. But you see these sides are not straight lines. They are not straight lines. They are not straight lines. They are again angles. Okay. And these angles, where can you find them? These angles are inside here. So actually the length of this side is equal to the value of this angle. Similarly, if you want to calculate this side B, it means we are calculating this angle C. If we are going to calculate this side C, we are going to calculate this side, this angle C. So here we have total 6 angles. A, B, C, A, B, C. Where A, B, C are and where these A, B, C are. These are on the surface. On the surface. And these A, B, C are the angles between the planes. Okay. The sphere between the lines. Look, this is one line, this is another line. So the first line is showing plane. So every plane has an angle with another one. Okay, like look at C. C is angle with B. Okay, with so all are connected here inside the center. So we have three sides which will also be in angles, and these angles are inside the sphere. We cannot see them, they are inside the earth, and these are the angle on the ground. We can reach to these points and we can use the terminology latitude, longitude, declination. So all these points can be calculated by those marine terminology. Latitude, I think the latitude are these lines. Okay, and longitudes are these lines, I believe. Okay, so these A, B, C points can be calculated with this basic knowledge of globe. Guys, let's have discussion. Any problem? Guys, come on, please. Ask question, otherwise it will be difficult. Okay. Hello? Do you hear me?
Yes, Mister.
Okay. First of all, you tell me how many angles are there in this triangle?
3.
6.
6, not 3, 6. Okay, because 3 represent sides and 3 represent the interior angles. The angles between the sides. These angles. The angle between the so 3 angles are between the line segments and 3 angles between the arcs. Simple. Look, 3 angles between these lines, which are cutting these lines. 3 angles are there, and 3 angles are outside between the arcs. Between the arcs. So they are angle between the arcs. And ABC are the angle between the planes. Means these lines where each plane is cutting. So total 6 angles. Here we don't have 3 sides and 3 angles like the ordinary trigonometry. So this A we will measure, in degree, and this angle is here. Similarly, if you are going to calculate side C, so side C means you are going to calculate the angle inside. Similarly, if you are going to calculate B, so B means we are going to calculate this angle B inside the ball. So total 6 angles, 3 angles for the angles between the arcs which are on the surface of the ball, and 3 angles are inside the sphere between the 3 planes. Okay, like you cut the first of all you draw 3 great circle on apple, and then you cut them with a knife and reach to the center of the apple. So you cut it in 3 planes. So each plane has an angle with the second one or the third one. Okay, so that's it. Okay, now to solve a triangle, a spherical triangle. Which one is this? This one, yes. Okay, and I'll open. This is from your book, these questions. Okay, examples and okay, this book reference I have given on the Moodle and even here in the module outline. Moodle, I think so far I didn't upload. Anyway, I'll upload it. So I think we can recognize now great and small circle. So I asked someone, Rukaya, can you tell me what do we mean by great circle and what do we mean by small circle? Rukaya, you are with me? Mahathir, do you hear me?
Yes.
Can you answer this question, please? What is great circle? What is small circle?
The great circle, the big circle.
What do you mean by big circle?
When you cut the
The sphere.
yes,
Hmm.
the circle in the center.
Yes. When it cuts this, it passes through the center of the circle. Okay. And small?
When you cut a small circle, the rod will be more reduced.
Okay. And what's a spherical triangle?
when you cut a 3 circle, we
Yes.
we get the triangle.
Okay, when we cut 3 great circle, okay, look this yellow one, and another I draw like this. Oh, sorry. Okay, and one more great circle I draw it maybe like. Okay, the back side of this circle, all of them have center. The yellow one has this is the basic thing, that is why I'm taking time on it. So it's back of the yellow circle which we cannot see, and this is the back of the red circle. So we got 3 intersecting point. Let this A, this B, and this C. Okay, and this is the center of the ball. So we connected here, we connected there. So first of all, this angle will be what? This will be C. Then we cut, we join the center from point C. So what will be this angle? This angle will be A. And similarly, this angle will be B. So this triangle is called spherical triangle. Okay. Now, from the equator, now I'm coming to the Earth now. Earth now. We have latitude. I think 90 latitude or 180. Okay. So I take one point here, because there will be some greater circle, another here, there will be greater circle, and one I take on the equator. Okay, so one point is here, and so they okay, 1 2. So okay, so our circle is like this. No, I wanted to explain another thing. For example, I was explaining about a complement which is required for the solution. If from here to here it is, suppose 20° north, 20° north, with the center of the earth is this angle. But what about the remaining angle? So the remaining angle, we subtract this from 90. So from here to the top, this angle will be 90. So here it comes the concept of the complement. If you have taken this point, so the angle of the with the center, it is, say, some this one is say 60° north. Okay, so how much will be the remaining? The 90° minus 60. Okay, and if we want to know this distance, so we'll simply subtract 60 minus 20. It will give us even this angle. Okay, so the complement is there. Now for the solution, we have one solution tool. Okay. First of all, the spherical triangle has 90-degree summit. Now, this is not a spherical triangle. Note it. If I draw it another way, say like this is the tool. Okay, I divide the tool into 5 parts. The 90 angle is here, right? So if our triangle is like A, B, and C. Suppose the angle here is 90 degrees, so we will write this A here. Okay, this is angle A. Now, with this, we'll write the side B and C. So A, B, C. Okay, guys. A, B, C are inside. If this is C, so this angle is C and this angle is B. So when you are selecting this point 90 degree, so we will write with it BC here. Okay. Now opposite to this in this shape, we will write its complement minus C, and we will write the complement of B 90 minus this will be capital C, okay, and this will be capital B, and this angle will be equal to 90 minus A, the same. The same. Anyway, we'll elaborate this next lesson. Here they are going to explain it, but no, this is not what I'm going to explain. Okay, then we have 2 rules. I'll explain next lesson. We are running short of time. So keep in mind, if you draw it in any way, generally the books give this shape is like this. They write here the 90-degree angle, suppose it's A, then it connect to the center. This is the tool, this is not about the sphere, okay? They write here B, they write here C, and opposite to C we write 90 degree minus C, and opposite to P we write 90 minus B, and in the center we write 90 minus A. Okay, we can also draw it like this. If we take this is A, we take this is B, this is C, then opposite to it, it will be 90 minus C, and it will be 90 minus B, and this will be 90 minus sorry, A. Okay, 90 minus A. So we'll go through it next lesson. Today, sorry, time went through this circle. So see you next lesson, guys. Thank you. Hello, you have another class now, huh? Hello? Hello?
Hello, Mr.
You have another class now?
Yes, yes.
Okay. So that's it for today, guys. Thank you.
Thank you, Mr.
Thank you, Mr.